Hey guys, about to lose my mind because I just recorded a lot of this and it went away. I don't know where it is. I don't know what happened. So anyway, this is finding exact area under the curve using the first fundamental theorem. And um, what we did last sections was finding approximating area, using Riemann sums, which is rectangular methods, and then finding exact area if it was a geometric shape. Well, today's lesson is basically saying, hey, if it's not a geometric shape, you can find the area of any curve as long as you use the first fundamental theorem, and it's pretty easy. All you need to do is integrate, and then there's bounds. You plug in the top bound minus the bottom bound, and whatever number you get, that's the answer. Okay, so let's try this again without it deleting. So what you're going to do is you're going to integrate. So normal integration rules: add 1 to the power, divide by the new power. So when I add 1 to the power, I get x to the 4th over 4. I don't need a plus c because I'm going to be subtracting, and that c would subtract out. So you never need plus c when you have bounds on your integral. First fundamental theorem says take the top bound, plug it in everywhere you see x. So I'm taking 3 and I'm plugging in for the x here. Then you subtract. That's what it says up here. This is the first fundamental theorem. It says subtract up there. Take 1 and plug it in everywhere you see x. The number you get is the exact area. So this ends up being 81 over 4 minus 1 over 4. So that's 80 over 4, which is 20 units squared. So that's the exact area under the curve. All right, so the main idea is you integrate, plug in the top bound minus the bottom bound. So here we go. We're going to integrate x squared. You get x cubed over 3 minus 3x. I integrated both of these. Put a bracket. You put your bounds. Don't put plus c because you're going to end up subtracting. You take the top bound, plug it in everywhere you see x. Then subtract, take the bottom bound, plug it in everywhere you see x. You always do top bound minus bottom bound. You can't just subtract in any order you feel like. It's always top bound minus bottom bound. When you're subtracting a quantity, make sure you're using parentheses. So this ends up being 8/3 minus 6 minus 1/3 plus 3. I'm distributing the negative for the second part here. And this ends up being negative 2/3 as your area under the curve. The reason why it's negative is because more areas below the x-axis than above. All right, next one. Remember, if it's not written as a power, rewrite it as a power first. This is x to the 1/2. So when we integrate, we add 1 to the power. So if you add 1 to a half, you get 3/2. Now, instead of dividing by 3/2, because we always divide by the new power when we integrate, we don't divide by fractions, we multiply by the reciprocal. So we're going to be multiplying by 2/3. And then I put a bracket to show the bounds I still need to plug in. Listen, you might as well just cancel this 3 and that 3 right away. And now you're going to take 4, plug it in first. So it's going to be 2 times 4 to the 3/2. Then minus, take 1 and plug it in. 2 times 1 to the 3/2. Well, 1 to the 3/2, 1 to anything is just going to be 1. So this is going to be minus 2. This is going to be the square root of 4 cubed, right? This number on the bottom is the root, and this number on the top is what you're raising the number to. So that's going to be 2 times the square root of 64, which is going to be 2 times 8. And so your final area, exact area, is 14. So this is how you find the exact area under the curve. The exact area under the curve. All right, let's try this next one. Integral of secant squared. Well, we should know this, is tangent. And you're going to plug in, put your bracket to show what numbers you're plugging in. You're going to plug in top bound first. So it's tangent of pi over 4 minus tangent of 0. If you look at the unit circle, pi over 4 is the coordinates root 2 over 2, comma, root 2 over 2. So when you do y divided by x, since the coordinates are the same, it's going to be 1. Tangent of 0, those coordinates are 1, 0. So when you do y divided by x, you're going to end up getting 0. So your area here is 1. Right? So